Okay, so in the previous video I showed you where this formula comes from. Okay, now in this video we are just going to go through some of the examples. Okay, the examples start from page 308 in your Pure Year 2 book. Okay, so the first example is find integral of x cos x dx. Okay. Now, in these type of questions, as you can see, that we've got a product of two different functions. Okay, so what you've got to do is you've got to identify what function are you going to call u, and what function are you going to call dv by dx. Okay, so the function that you call dv by dx, you're going to integrate it, and the function that you call u, you are going to differentiate it. Okay. And as you can see, when you go on to this bit of the formula, you've got v du by dx. Okay, so always try and have your u as the one that, let's say for example in this example, your u should be x, because when you differentiate it, you are actually going to get 1, and you will get rid of that, and you will just be left with the integral of cos x, which then you can integrate easily. Okay, so I am going to let u be my x, so du by dx is 1. I'm going to let cos x be my dv by dx, so that means my v is going to be minus sine. Actually, just sine x, yeah, because I'm integrating. Okay, and then if I plug that into my formula, I am going to get, so write down the question again, equals uv, which is x sine x, minus, and I've got v, which is sine x, multiplied by 1, which I'm not going to write, and dx. Okay, and then in the next step, all you have to do is simply integrate sine x, and that will give you minus cos x, so that all becomes plus cos x plus c. Okay, example 2 says find the integral of x squared times ln x. Okay, so here again you are going to think about what are you going to call your u and what are you going to call your dv by dx. Okay, so in this case you're better off letting ln x as your u, because when you differentiate it you are going to get 1 over x, and you haven't learned how to integrate ln x yet. Okay, but even if you did know, in this case make your u the ln x function. Okay, so du by dx is 1 over x, dv by du is x squared, and that means your v is going to be x cubed over 3. Okay, now follow the formula again. So x squared ln x dx equals u times v, which is ln x times x cubed over 3, minus v times du by dx, which is 1 over x dx. Okay, so what's going to happen is I'm going to get rid of that, and now I've got a function which I can integrate easily, so I'm going to get x cubed over 3 ln x minus a third, and if I integrate x squared, I'm going to get x cubed over 3 plus c. Okay, so altogether I'm going to get x cubed over 3 ln x minus x cubed over 9 plus c. Okay, I'm not going to show you what that is, because you can multiply that out. Okay, third example is integrate x squared e to the x dx. So here again, actually it's better if we call x squared as our u, because when we differentiate it, we are going to be reducing the power. Okay, and that's something that we want. And also you'll see that this is an example. Actually, I'm going to wait until that happens. I'm going to ask you a question, okay? Right, so u equals x squared, du by dx is 2x, dv by dx is ex, and when I integrate that, I'm going to get ex again. Okay, so as you can see, if I had made this ex as my u, and if I differentiated it, I would have still got ex. Okay, so it wouldn't have made any difference. But if I make x squared as my u, it does make a difference. Okay, so I am now going to apply the formula. So uv, which is x squared ex minus v times du by dx, okay, and watch what happens. Okay, so now I've got to integrate ex times x. All right, so again, what I'm gonna have to do is now apply integration by parts formula again. Okay, but just to this bit. So what I'll do is I'll do that separately. Okay, so I'm gonna do this here. So this time I'm gonna call my ux. So my du by dx is 1. I'm gonna call ex as dv by dx, and that means my v is again going to be ex. And I'm just going to be applying the integration by parts formula there. So I am going to get uv minus v times du by dx, which is just 1. Okay, and now I am going to get ex minus ex plus c. Okay, and what I now have to do is I've got to plug this in there. Alright, so I'm going to go back here. Okay, and I will now have x squared ex minus 2 ex minus ex, okay, and plus c. So that gives me x squared ex minus 2x ex plus 2ex plus c. Okay, be very careful with your signs, especially if you've got a minus there. Okay, loads of students miss that out, and they you know, forget to put this big bracket there, and they always get this last sign wrong. Okay, so be very careful with your bracketing and your signs. Alright, now let's go to example 4. So example 4 says evaluate, and I've got ln x, okay, and I've got to leave my answer in natural log. Now you must be thinking, well, I don't know how to integrate ln x, and is that even possible? But it is possible using integration by parts, and what we're going to do is we are going to imagine, or we're going to actually make use of the fact that we've got 1 times ln x, okay, and I'm going to call my u ln x, so that means my du by dx is going to be 1 over x, and dv by dx is going to be 1, that means v is going to be x. And now I'm going to use integration by parts, so that gives me uv, which is x ln x minus, and then I am going to have x, okay, v times du by dx. There you go, and that gives me, and actually this is all inside limits 2 to 1. Okay, so what I can actually do is put 2 to 1 here and leave 2 to 1 there. I don't need this big bracket there. Okay, so that gives me x ln x limits minus, and I've just got 1 dx. So I've just got to integrate that, and I'm going to have x ln x limits to 1 minus x limits to 1. So basically what I've got is x ln x minus x all to limit 2 to 1. Okay, and that gives me 2 ln 2 minus 2 minus 1. 2 ln 2 minus 2 plus 1. Okay, because ln 1 is 0, and that will give me 2 ln 2 minus 1 is my final answer, and I want to leave my answer in log form. Okay, so watching these examples, you should be able to do exercise 11F, okay, which is on page 309.